Good job. Tomorrow we will read the lab before we go in there. You will be judged.
And it was a real thing that was going down in New Mexico.
You will be judged on how much of the product you make. So tomorrow we will let the copper dry overnight, and then on Friday we'll bring the copper in here and you can measure how much you produce. So it's going to be a 2-day lab on the quantitative analysis. But we'll finish it in here. So I'll give you about 5 minutes to work on your practice here for this quiz on Friday. C is correct.
Good job.
And number 6.
No, it's just all day.
Michaela?
How many moles are
These are constant.
B is correct. Number 7. Sophia?
How many moles of silver atoms are in 1.8 times 10 to the 20,000 silver output A 3.0 times 10 to the negative 4?
And that is correct. Number 8, Heather?
How many atoms are in 0.075 mole of titanium? And I said D, 4.5 times 10 to the 26.
And that is correct. And number 9, Heather?
How many molecules are in 2.10 mole CO2? And I said D, 1.26 times 10 to the 24th mole.
That is correct. Number 10, let's go with Eliza.
What would be the average mass of 6 atoms when I put A 1.0?
Excellent. Now these two I forgot to get on the handout. On number 11 and 12, it says, what is the molar mass of AuCl3? And what is the molar mass of NH42CO3? So I'll try to blow these up for you. D is correct. Nice job. So anybody got 12? Sophia?
What is the molar mass of NH4 and I put C.
And 12 is C. Nice job.
I don't know how that came out. You go to carbon, carbon on the
Background.
table to see that 1 mole is 12.01. So that's going to be what you divide by.
What's 1 mole? I don't get that.
Why do you always put 1 mole on top?
Well, because if you try to find your grams, that's telling you how many grams are in 1 mole of carbon. And that's what you're trying to get to.
You have to label your numbers. They don't teach this in math class.
Wait,
Like,
so you look at carbon.
So look, if you look at this periodic table, and you see, the numbers below it has all these weird decimals and all that. That's telling you how many grams are in 1 mole of that compound.
But question, why wouldn't it be 2 mole or like 3 mole? Like, how
Well,
do you
it
know
would
that?
be if the question was like this. If the question was, let's see, if the question was C2, H, and then O3, now you pull a 2 mole out.
Oh,
So these are going to, your subscripts are going to tell you how many moles
And
you
then
got.
you'll still put 2 mole over 12.01.
And that's what the next question is asking. This first one is just asking what percent. That is going back to multiplying the subscripts. So this first part is just dividing.
yeah, this is going to be grams here, what you're seeing there. So the grams cross out, and you're left in moles. So the percents always go to grams, which is a great point. But when you're finding the molar mass, which was the original question that he was telling you about, then you're going to have 2 moles there, like he said. So don't try to combine the two, because if you try to combine the two, you get confused.
Well, because they want you to do it both ways. They want you to find percent composition, and then they want you to find the formula. And the formula is like this up here. That's what they mean by formula, is these elements and then their subscripts. That's what they mean by a formula.
okay, wait, how did you put that into the calculator?
So you're going to do, I know it has a multiplying sign here, which is kind of confusing. So on my papers normally put divide just to just to let me know that I'm dividing. So it'd be 65.5 divided by 12.01.
Because the one doesn't like
Right. So now these grams are going to cross out. You're going to cancel each other. And this is going to tell you, I don't know, what would it, it's like the...
Yeah, this goes to mole. Remember, follow your units. So these grams cross out, and your answer will be mole here. And mole is important because that's the unit right here. The subscript is in mole. That's why you're trying to get to the mole. Like you see here, mole. Like he mentioned a few minutes ago with the C2H03. One, right?
Yeah, I had to do a little bit on my own.
I'm starting at
Okay, 5.5. This will be more.
Yeah.
Blaster, yeah.
Okay. So now you have these. I already divided these, so these are already on my paper.
Oh boy.
So now what you're going to try to do is get a whole number out of these. So you see how I've already got one. That's by itself. It's one. There's no decimal points on it. Now I have to get these.
Those are close enough. So he's just going to stay there. When you get to like a 0.0, you can round that off. So it's going to be 3. You don't have to be like extreme.
Yeah.
There is some degree of close enough. Spell work, we're examining what is the empirical formula for C2H8N as far as the mass associated with that. So the first thing you do is find the mass of the empirical formula, and then when you're given a molar mass, we have to determine what the formula is. So what's 2 times 12?
24. Here.
24? You want to finish that for us?
Yeah, I can solve this.
Okay.
And then you divide by the smallest one.
No, you're going to add all those up because this is you're dealing with the molar mass here.
Oh, okay, we're doing molar mass. Okay, so that's 38. This is 38. That's 46.
Very good. So they've given us a molar mass of 46. So what does that mean?
I don't follow.
Well, this is the actual formula because they've given us the molar mass of 46.
So this is true.
Yeah, so 46 divided by 46 is 1. So the empirical and the molecular formula is this, C2H8N.
Oh, so it's like a true or false statement.
Yeah, basically.
So that is true.
That is the empirical and
That,
molecular
like,
formula.
okay.
Yeah. Now, sometimes you don't always have the case. Like yesterday, we had C6H6 for benzene. That's benzene. We'll just put a B. Then we had C2H2, and that was acetylene. We'll just put an A. And the empirical was CH. Now, this does not exist. So sometimes, yeah, this is the empirical, but it's not a molecular formula. You can't make CH. Yeah, carbon hydrogen, because carbon actually wants 4 hydrogens.
Right.
Right.
So it can't
Now it can have, if you have 2 carbons there, then you can do carbon bonding to itself. And then you have 2 carbons off this. You can have a hydrogen here, or you can have a triple bond in the center. So there's a lot of possibilities associated with this that you don't see with this.
Right.
You see 2, 4, 6. So these are going to share here, and that gives you 8 around it. And these can share here, and that gives you 8. But you can't have that set up here. It's just not possible.
Right.
So these will exist too. This one just won't. So that is both the empirical and molecular.
Right.
Yes, Kayla, that is correct. Nice. Kaya. I said Kayla, but it's Kaya. I'm going to get it right.
Eventually.
I will. What'd you say, Sierra? D is correct. Number 3 is...
C. What was number
3 is C.
Okay, how do you get that?
Well, you have 5 molecules of isopropyl alcohol, and it says how many hydrogen atoms. So you take 5 times. What's 5 times?
15.
7. 7 right there.
Oh, yeah, it is.
D is correct. Michaela?
No.
D is incorrect.
Oh my god, I'm the one.
Sierra, B is correct.
Okay.
A is correct. And number 8, you're going to divide by 602 sextillion, or 6.02 times 10 to the 23rd.
Divide what by that?
Problem. Where you have 1.8 times 10 to the 20th. So on your calculator, you're going to go 1.8 exponent, see the E right there, exponent 20. And then you're going to divide by 6.02 exponent. So you should see the E there on your calculator. And then 23, and your answer is going to be 2.99, which is to the negative 4th. So we're going to round that up to 3. So we're saying A. Did we say 7 was A?
Yeah.
So you do the same thing for 6?
I'm gonna write my essay on that.
Number 1 is not D.
Oh, hey.
Raise your hand. Cameron. A is incorrect. Substance. Which substances have the same empirical formula? Now, empirical, remember, is the same ratio, like 1, 2, 1, or 1, 1, 1. All right, go ahead, Alyssa.
B.
Number 2 is not B.
C.
It is not C, so you got to figure that out on your own. The answer is not B. The answer is not A. It says how many hydrogen atoms are in 5 molecules of isopropyl alcohol. Now, how many hydrogens do you see in the isopropyl alcohol? Raise your hand.
7.
There are 7. So, raise your hand if you can tell me what 7 times 5 is.
35.
Jimmy?
46.
Jimmy. So, do you see an answer that might be 35 on there?
No.
Tomorrow, we'll be on quantitative analysis, which is going to lead us into stoichiometry, where you're going to determine the math associated with a given amount of solution and metal, specifically a nail. You're going to react a nail with copper chloride, and we're going to show you how much you're supposed to predict to make. And that's stoichiometry is a quantitative analysis, and then you're going to finish the homework that I'm giving you in a minute. You have it on your paper.
I have a question paper on the test.
I gave it to you when you came in.
I don't have it.
For the compound whose percent composition is shown. C.
1 is C.
Do I get points for that?
Yes. And number 2.
Do we keep these tests?
Yes. It's basic quiz review for Friday. Quiz review for Friday. And I'm going to add 13 to it. So there's 12. I'll add 13. You get 25. Number 2. Anybody? All right. Go ahead, Josh.
Which substances have the same empirical formulas?
A. B.
Oh, B.
No, the answer is not B.
C. D.
You only get 2 chances, so you might want
I
to.
got it. D.
The answer is D. So number 2 is D. Now, with this, empirical is the ratio, like 1, 2, 1, or 1, 1, 2. So you're trying to find the ones like here you see 1, 2, 1 is the same as 1, 2, 1. So that's why D is correct. It says D is, I think, 2 and 3. So the ratios are correct.
And the answer is C, D, or A.
3 is not D.
C.
3 is C. And number 4. Number 4, talking about clementine oranges. Who's got that? Number 4. How about Emma? You like oranges, Emma? You don't like oranges?
What I do.
Okay. Sean, do you have number 4? Number 4 is not A.
C.
Number 4 is not C. Try it again.
It's D.
It's obviously
It's D.
Well, what you're going to do, you're going to take 15.
D.
Well, you're going to first take a dozen and divide it by this, then multiply times 15. So a dozen is this mass. Everybody understand that? So 12 divided by 744. Take that answer, multiply times 15.
Moles of, what is that? Some atoms are 4.8 atoms of
No one got caught. 6.02 times 10 to the 23rd atoms of tungsten. So the symbol for tungsten, I believe, is a W. Tungsten. Where is it on there? Yeah, tungsten's W74. So we have 1 mole of that, of W. And what happens, the atoms will cross out. So if you take 23 minus 23, what's that equal to? 0. So you're really just doing 4.8 divided by 6. So it's going to be a fraction. So you're going to see a -1. So your options there, if you could do basic math, is most likely going to be this answer. I need to put it in the calculator. Well, they're saying the answer is B. So if you do the math here, what's 4.8 divided by 6.02?
2.2, 2.4 over
5.
So the answer is
Yeah. So that makes a difference then. So 25 minus 23 is 2, right? So that's going to be 10 to the 2. Then you move the decimal over, it's going to be 10 to the 1. So they're rounding this to 8 times 10 to the 1, which is B. And that is correct. See how we did that? So if you 8 divided by 6.0, B7 is not B. PI 0.075, you multiply it times the mole, and then you'll get your answer. So it's going to be a fairly large number like you see up there. It should be less than 23rd because you've got 0.075. 1 times 23rd is going to be the 23rd. It is not A.
You're over like 9. I got C. C, I got C.
Now, Emma, let me help you, right? If you took 1 times this number, it would be the 23rd. If you take 0.0, you're removing this exponent power. So if you took like 0.1 times it, it would be 22. 0.01 times it, it would be 21. So it's going to be less than 23. You see anything up there that's less than 23?
Oh, C.
D is correct. So math reasoning can really be helpful to you on like the ACT to improve your speed on it because it is a time test. You want to think about that.
0.10 moles CO2. Yeah. And the answer to number 9 would be B.
What'd you say?
B.
B? B is not correct.
D.
D is correct.
Thank you.
Once again, you're taking this number times a mole. So 2 times 6 is going to be 12, right? So you can see that there. 2 times 6 is 12. Everybody understand that? That's how you get that 1.2.
Use the following information to answer the next question. An average bushel of apples has a mass of 10 kg, which contains 5 dozen apples. What would be the average mass of 6 apples?
Oh, wait. So it's
And I got, hold up. It's not C.
Okay, so you're saying what's the answer?
I'm saying that the answer is A.
D.
D.
D is not correct. Raise your hand, John. C is not correct. What's the molar mass?
3 ball.
Raise your hand. 11 is
Sean, you do it.
Sean.
I told you the answer. It's C. It is.
Right,
I
I
see.
Say C.
That's it. All right. C.
11 is not C.
All right. What is it?
11 is right here. You're taking the periodic table mass of gold plus 3 chlorines. 35 times 3 plus 196. So you know it's going to be over 196. These two can't be correct. NH4 2 CO3.
It's A.
Raise your hand. A is not correct. B is not correct. See what it does.
Right.
Yep. Push down. Yeah, it bound up. See how?
Oh, we were going good there for a minute.
Really good.
I feel excited.